Hi, welcome to this video where I will be taking you through a simple example of a statically determinate beam analysis performed in a finite element analysis software, and we will see how the results correlate with the hand calculations. So the exercise for this particular example is to calculate the reactions for a simply supported beam with an overhang. We have a pin support at point A, as you can see in the figure, and there is a roller support at point C. The total length of the beam is 6 meters with 3 divisions of 2 meters each. Then you have two types of loads applied on this beam. You have 15 kilonewton point loads at points B and D, and uniformly distributed load of 2 kilonewtons per meter on the members BC and CD. So to start with the demonstration, I will open up the software first. So you can open up the software either from the start menu and go into MIDAS Gen, or you can go to the desktop and double click on the icon. Okay, so here is the blank MIDAS Gen window. You can go to File and click on New Project to start a new file or new project, and that's the new model view. Model view is the modeling space, which is green color. Okay, now you will also find, as soon as you click on new project, there is a coordinate system at the center of the model view. So the MIDAS software follows the Cartesian coordinate system, where x and y are the horizontal axis and z is vertically upwards. We can save the model by going to save, and let's type in some name. Okay, so now we don't have to worry if we lose the information or not. It will be saved. So to begin with, first of all, let me give you a brief introduction to the different features or options that we have here and where to access them. So just like any Windows based software, you have a main menu system at the top, like File, View, which is used for displaying the model in different ways. Then you have a model menu. So the model menu is used for accessing all the modeling or drawing tools, like you can create elements or basically lines or faces or plates using different type of drawing tools which are similar to AutoCAD. Then you have some properties assignments, like you can assign materials or sections to your members. You can also assign boundaries like pinned or roller supports, which we will do in this particular example. Then we also have loads in the load menu. So any type of loads like point loads or element loads can be applied using the loads menu. Then the results menu helps you to see the results. For example, we will see reaction results for this particular example. Then the tools menu has some useful options like unit system. You can change the unit system anytime in the modeling process. So for this particular example, we'll set the unit system to kilonewtons and meters and click OK. You will also notice that at the base of your screen you have a unit system option, kilonewtons and meters shown here. You can change the units using the drop down. This here, the gray part, is also called the model view. So this is where the modeling will take place and you can visualize the model graphically. On the right side are the display tools like zoom options, then you have rotate options, then you have the isometric view, top view, right view and front view. Then there are dynamic view options, like you have the dynamic zoom and dynamic pan and rotate dynamic. So we will use these features one by one in the modeling process. Then there is a tabbed toolbar, which is basically a shortcut to all these modeling features. So if you have to model an element, create an element, you can go to element and click here, create elements, to get that feature, the same feature which you can get from the menu system. Also, all these menu features can also be accessed by simply right clicking on the model view and accessing the different features here. So you have different ways of getting an access to the modeling tools. Okay, so let us start by setting up the analysis interface. So first of all, for any type of structure, we can select if we want to do a three-dimensional modeling or a two-dimensional modeling. In this particular example, you can see that we can see the results only in two-dimensional. So we can get the vertical and horizontal forces. So we'll perform the modeling also in two dimensions. So we go to model, structure type, and set up the two-dimension plane or XZ plane. The XY plane is the horizontal plane, so we want a vertical plane, so we select XZ plane. Okay, and as soon as we select it, we shall get all the forces and everything in the XZ plane only. So we should be very careful in the modeling. We need to model everything in the XZ plane, apply all the loads and boundaries in the XZ plane only. Now we go to the modeling wizard model and select structure wizard and create a beam. So simple structures like beams, columns, or arches, they can be easily modeled from the structure wizard. So I go to beam and enter 3 at 2.0, which is 3 segments, 2.0 meters or 2 meters each. Add, and then it also asks for the material and section properties. So each beam element or each finite element, these are all finite elements here. So 3 finite elements we will be modeling. So each element should have a material and section property. So we have to define some materials. We haven't defined any yet, so what we can do is just initialize it with some material or section ID 1. All the materials and sections are saved within the program as numbers. So if we enter a number, so generally we enter 1 and 1 because these are the default values, and the element will be assigned with the material ID 1 and section ID 1. We click OK. So that creates an element. It creates a beam basically with 3 finite elements, 3 beam elements. Then we start defining some materials and section. So we go to model, properties, and select material and add, and we can define steel, concrete, or user defined, any type of user defined material. So for this particular case, let's select user defined, enter the name as material 1. You can see the material ID which we entered as 1, so let's keep this as 1. This is the default number, and we enter the modulus of elasticity or Young's modulus value. So 3 into 10 to the power 7 kilonewton per meter square, and click OK. So one material gets added. Close this. Then we go to model, properties, and section to define the dimensions for this line. Add and select DB or user tab and select solid rectangle. Name this section, so that is section 1. Select user and select the enter the dimensions as 0.5 meters by 0.5 meters and click OK. So that is 500 millimeters by 500 millimeters beam. OK, and close this. Sorry. Okay, so as soon as you select or define the section, the shape appears on the screen. Now I will change this to the XZ plane or the front view. Okay, Y is into the plane, so this is the XZ plane view, and that's your section dimensions you can see. Now we have we have entered some nodes and elements in this structure. So how to access the information for this model, how to see what we have entered in the model. So for that there is a works tree. If you click on works here, you will find that all the information for this model has been listed out in the works tree. You can also highlight certain parts of the model by just double clicking on the works tree features. For example, if I want to highlight all the nodes in my model, then I just double click on nodes to highlight all the nodes here. So we have 4 nodes. How each node has a particular number associated with it. If you want to see the numbers, we can just click on node numbers here, and you can also to make it more clear, we can change this display into a line display. So by clicking on this option, we get back just a line. Okay, so these are the node numbers. Then if you want to see each and every element number, we have 3 elements. You can see here beams 3. Double click and all the beams get highlighted. You can click on the node, the element number, to see all the beam element numbers 1, 2 and 3. Now talking about the highlight and selection option, we have other ways of selecting the objects as well. So that come under the category of selection unselection tools. So if we were to unselect everything or remove the highlight from every element, then we click on unselect all, so everything is unselected. To select a particular element, we can choose the select single option. If I click on select single, we get a crosshair as shown on the screen, and the crosshair means that you are in the selection mode. You can simply click on a given beam to highlight it, or you can create a window. So I can create a window like this to highlight from left to right, to highlight everything within the window, or I can create a window from right to left so that anything that touches the window and anything that is inside the window gets selected like this. So these are all the selection and unselection tools. So I will again unselect all. Okay, now how to pan or move this object, this structure, how to zoom in or zoom out. We can simply use the mouse to do that. The middle mouse button, if we scroll in or scroll out, we can zoom in, zoom out. Once you have achieved a particular zoom, you can just left click on the screen to escape the zoom mode, and to pan or to move this object, you can press the middle mouse button and a hand will appear and you can just move it. If you want to rotate this model, you can press Ctrl and press the middle mouse button and rotate the model. Okay, also all these things can be done from the icons here. So this is dynamic zoom, so click on it to zoom in or zoom out dynamically. Then this is pan and this is rotate. Okay, okay, let's now define some supports for the structure. So we have a pin support here and a roller support here. So I'll unselect everything and go to model, boundaries, supports. Now the software does not understand what is pin and what is roller by the actual words pin and roller. So we need to specify the exact properties of a pin support and the properties of a roller support. So basically, for every finite element software, we have for a given node we have 6 degrees of freedom, 3 translation and 3 rotation. That is displacement along the x, y and z axis, and rotation about the x, y and z axis, which you can see on the left side here. You have dx, dy, dz, which are the displacements along the different axes x, y, z. Rx, ry, rz are the rotations about x, y and z. So a pin support in our case basically allows rotation. That means we will not apply any restraint to the rotation. So that means all these boxes we will not tick, we will leave them blank. That means rotation is allowed for the pinned support. However, the pinned support restricts displacement vertically and horizontally. So in our case, we will apply a dx and dz restraint for the node number 1. So we have selected dx and dz restraint, and now we'll use the select single option here. So click on select single and a crosshair appears, and we will create a small window just including the node here. So remember to create the window from left to right, or what you can do is I'll unselect everything and again select, so you can just click on this node to highlight it. Okay, and once you have highlighted it, click apply, and you will find a symbol of a support appearing. You can see that it has got 6 small triangles. Some are green and some are black. The black ones are the degrees of freedom which are not restrained. So if you go from the left or from the right side and go clockwise, you have the triangle 1 representing dx, triangle 2 is dz, dy, and triangle 3 is dz. Then you have rx, ry, and rz. So we have restrained dx and dz. So all the restrained ones are shown in green. So dx is restrained green, dy is free because we don't need to provide any dy support, as we are only doing a 2D xz plane analysis. So the dy is automatically restrained or not considered in the analysis. And then dz is green. Then we have rx, ry, rz all black, so rotation is allowed for the pinned support. Next thing is applying a roller support. For a roller support, horizontal motion is allowed, but vertical motion is restrained. So that means we need only dz this time. So check off the dx option, click dz, and this time select node 3 and click apply. So that's the roller support. So that's how the supports have been defined. Now close this. So sometimes what happens is if you close it from here, the tree menu from the crossbar here, so the tree menu disappears, and if you want to get back the tree menu, you can just right click on this blank part on the right side and click on tree menu 1 and select the tree menu from here. Okay, now we will apply some loads on this structure. So we start with the point loads first. Okay, let's look at the drawing that we have in the PDF where the loads are applied. So 15 kilonewton and 15 kilonewton at point B and D. So first of all, before applying any type of load, we give the load case a name, because whenever we are seeing the results in the finite element analysis software, the results are always displayed under a particular load case. So we give the load case a name. So we go to loads, static load cases, and give a name to this load case. Say P. P is the notation for the concentrated point load, 15 kilonewton. So P, and type is user defined. Add. Then we can select another load case name. This one is the UDL, again user defined, and add. So we have selected 2 names. Now close this. Then we will start defining some values or assigning some values to these names. So load, first type of load is the concentrated load of 15 kilonewton, which is nodal loads. So select nodal loads here, select the name as P, and in the FZ category, because the load is acting vertically downwards, so we enter -15, minus because it's in the downward direction, and use the select single option to select the 2 nodes in question. So node number 2 and node number 4 here, and click apply. So 2 15 kilonewton loads are applied now. The next thing is we select we assign the uniformly distributed load. So I'll close this, and again I'll go back to the PDF to see how the load is being applied. So if you see on the screen here, you will find that 2 kilonewton per meter is applied from the midpoint of member PC to the end of the beam, and that is point D. So we need to create a midpoint here. We only have 3 segments. So what we do is, in the finite element software or MIDAS Gen, we divide this particular member in 2 parts. So we go back to the model and we go to model, elements, divide. Okay, now select the element that we want to divide. So select single and just click on this element number 2. Okay, and number of divisions is 2, so 2 equal divisions we want, and click apply. So now a new node number 5 appears here, and that element is now divided. So we have element number 2 and element number 4 for representing the member PC. So I'll close this, and now we go back to loads, element beam loads. So for uniformly distributed loads or any type of load on the element, we use this option, element beam loads. Now this time the name that we want is UDL. Okay, the load type is uniform load, so the symbol or the diagram can be seen here. Okay, now select the elements which you want to load, or where you want to apply the loads. So I selected these 2 elements here. Okay, just create a window, and the direction of application of the load is global Z or vertical direction. Okay, and the value of the load is -2, minus because it's in the downward direction, so -2 kilonewton per meter. Always check the units for the load application. If they're not in the correct units, you can change it. You can always change it from the status bar here. Click apply, and the load gets applied on the structure. Okay, now if you want to, if you wish to see or display the value of the loads, you can always right click in the works tree on the load case and go to display to show the values. So this is 15 kilonewton, and right click display here to show -2 kilonewton per meter. Sorry. So I'll undisplay this and undisplay the nodes and element numbers so that it's more clear now, and we'll run the analysis. So to run the analysis, we go to analysis, and say perform analysis, or you can press F5 or click on this button here. So perform analysis. Okay, analysis is done. The message window will show you how the different steps in the analysis are being carried out. Now once the analysis is performed, you will find that you will have 2 locks shown here, one unlock mode or the pre-processing mode, and the other the active locked mode, or called the post-processing mode. This is the mode where you can see all the post-analysis or post-processing results. So no modifications can be done in this mode. If you want to modify the model, say you want to change the length of a particular element or add another beam, you have to unlock the model first and then modify. So I'll go to post-processing mode here to see the results. And for the results, first of all, since we have 2 different cases, we need to combine them because we want to see the reactions for the total loads on the structure. So combine these 2. So we go to results and click on combinations and enter a combination. So give a name, combination 1. The type of combination is additive or the summation. load cases to be combined are P and UDL, both with a factor multiplied by 1, and then close it. Then go to results and go to reactions, reaction forces, and let's select the combination. So combination 1, Fxyz, that is, we include all the vertical and horizontal reactions at the same time in the display. We have no moments for this particular model, so there no need to check on any mx, my, mz. So Fxyz, and we check on values to see the value of the reactions, and we click on the small box here and change the decimal points for the display, say 2 decimal points, and click OK. So that gives these reactions. We have about 36.75 and minus 0.75 kilonewton here. To show them, to get a bigger display of the numbers or the values, we can use the display option. So this icon, which resembles a television screen or monitor, if you click on this icon, you can choose different modes of display. So if I go to display option, I have an option called font node output value. So here I can change the font size of the node output. So make it say 12 and click OK. So now you get a bigger display. So you have minus 0.75 kilonewton on the support A and 36.75 kilonewton and the support C. Let's see how the hand calculations correlate with these values. So I'll go back to the PDF. So hand calculations, we have this model. So naturally, because all the loads are in vertical direction, we will have zero horizontal reaction at the support A. So we will only have VA and VC vertical reactions. So which can be very easily found by simply taking moments first about A and equaling them to 0, and then moments about C and equaling them to 0, and by checking, and we can check the results by using a simple check, that is total vertical forces should be 0, so that is VA plus VC should be equal to the applied loading, and that gives us the values, the theoretical values here and the MIDAS gen values over here. So they are same, exactly same. That shows that the analysis is performed correctly. Okay, now we can also see the results in a tabular format. If I go to results, result tables and reaction, I can select combination 1 and click OK. That shows the reaction at node number 1 and 3 where the supports are applied. Node number 1 is support A, node number 3 is support C, and these are the vertical reaction Fz, and the summation of the reaction, that is the total loads acting on the structure, is 36 kilonewton. So that concludes this session of statically determinate beam analysis and reaction calculations for the same beam. All the materials for this particular tutorial can be found in the description of this video, this YouTube video, and we have many more examples in this channel, so stay tuned to the tutorials of MIDAS Gen channel on YouTube, MIDAS UK page of YouTube, and we have further examples of statically indeterminate and truss analysis, buckling analysis, etc. So stay tuned for more videos. Thank you.